Show it a clock, not a smart clock, not a digital display, an analog clock, the kind with hands, the kind that has hung on classroom walls since before your parents were born. Ask it what time it shows. Half the time, it's wrong. Not a cheap system, not an early prototype, the most expensive piece of technology ever built by human hands. The system that just solved International Math Olympiad problems in seconds. The system that passed the bar exam. The system that $285.9 billion, more than the GDP of most countries, has been poured into building, refining, and deploying into every corner of modern life. Analog clock. 50% error rate. That's not a quirk, that's not a bug on the list for the next update. That is a window into something much larger, and much darker than a missed hour hand. Because here's what nobody building this thing wants to say out loud. We may not actually understand what we just created. Picture a room, no windows, just a screen, a clock on the wall, and the most expensive piece of technology ever built by human hands. You show it the clock. It gets it wrong. Not sometimes, not on bad days, half the time. 50%, a coin flip, the same odds as guessing. And here's what makes that number so strange. This is the same system that just solved problems from the International Math Olympiad. Problems that take the world's best mathematicians hours to work through. It ripped through them in seconds. It passed the bar exam on its first attempt. It answered graduate-level biology questions that would stump most PhD students. And then you held up a clock. The kind hanging in every school classroom since 1890. And it shrugged. That should bother you, not as a curiosity, as a warning. From people who still don't fully understand what they built. As of February 2026, the United States alone has poured $285.9 billion into artificial intelligence. That's not a budget, that's a belief system. It's the kind of money that moves history. The kind spent on moon programs, on nuclear arsenals, on the infrastructure of entire nations. And it has been placed with extraordinary confidence into a technology that cannot reliably read an analog clock. Now, before anyone calls this unfair, yes, AI does extraordinary things. The breakthroughs are real. The capabilities are genuinely unlike anything that came before. This isn't a story about AI being useless. It's a story about something more unsettling than uselessness. It's about a gap between what AI can do and what we've been told it can do, between the pitch and the product, between a thinking machine, and a very fast, very expensive autocomplete. Here's a question the industry doesn't want to answer. At what failure rate does a tool stop being useful and start being dangerous? If a surgeon was wrong 50% of the time on basic anatomy, they wouldn't be called cutting edge. They'd lose their license. If a bridge engineer miscalculated load-bearing weight half the time, we wouldn't call it a jagged frontier. We'd close the bridge. But AI gets a different set of rules. Its failures get rebranded as quirks. Its limitations become proof that the next model will be better, and the money keeps moving. Because the people closest to this technology have a problem that has nothing to do with the technology itself. They have spent so long inside the story they're telling. The story of the singularity, of the great leap forward, of the machine that will finally think like us. That they can no longer see the clock on the wall. They see what they want to see, and that might be the most expensive mistake in the history of technology. 73% of AI experts expect positive outcomes from continued investment. Only 10% of the American public says they're more excited than worried. 10%. That's a lower number than the people who believe the moon landing was staged. That gap between the people building it and the people it's supposedly being built for isn't a communication problem, it isn't a PR problem, it's a warning signal, and the longer it goes unaddressed, the louder it gets. But to understand how we got here, and what's actually at stake, you need to see exactly how the machine fails, not the dramatic failures, the quiet ones. The failures happening right now inside the tools millions of people are using every day in ways that nobody is stopping to measure. And once you see them, the clock on the wall looks a lot less funny. In 2023, a lawyer named Stephen Schwartz submitted a legal brief to a federal court in New York. It cited 6 cases, precedents, real court decisions with real docket numbers, and real judges' names attached to them. None of them existed. ChatGPT had invented them, whole cloth, complete with plausible-sounding parties, jurisdictions, and rulings. And Schwartz, trusting the system that had just passed the bar exam, submitted them to a judge without checking. The judge found out. Schwartz faced sanctions. His career nearly ended. That story made headlines. What didn't make headlines was that it kept happening. Different lawyers, different cities, different courts. The same pattern, AI producing confident, detailed, completely fabricated legal citations, not guessing, not hedging, stating with the full authority of a tool that had just demonstrated it could beat human experts on their own turf. Researchers gave it a name, the Jagged Frontier, and once you understand what it means, you can't unsee it. The term comes from researcher Ethan Mollick, and it describes something that should make anyone using these tools stop and think. AI performance isn't a straight line, it isn't even a curve, it's a jagged edge. Exceptionally sharp in some places, completely collapsed in others, and with no reliable pattern to tell you which is which before you lean on it. Pass a bar exam, yes. Count the letter R in the word strawberry. No. 3 R's. There are 3. A 7-year-old can find them. The most advanced language model in the world, built on hundreds of billions of parameters and trained on more text than any human will read in 1,000 lifetimes, gets it wrong. And then Google's AI when asked, as a joke, how many rocks a person should eat per day, told users to eat 1 rock daily. The recommendation was traced back to a satirical article from The Onion. The system couldn't tell the difference between a parody and a source. It just found text that matched the pattern of the question and delivered it with the same confidence it uses to explain quantum physics. That's not a bug they patched and moved on from. That's a feature of how the system works. It doesn't know what it knows. It doesn't know what it doesn't know. It produces output that statistically fits the shape of the question, and then stops. No alarm, no disclaimer, no flag that says, check this one. Here's the question that should be asked in every boardroom, every government office, and every courtroom where AI is currently being used. And isn't. At what failure rate does a tool become a liability? We have answers to this in every other industry. A diagnostic test in medicine needs a false positive rate below a defined threshold before it can be approved for use. A structural material has to pass load-bearing tests before it goes into a building. A pilot has a maximum number of errors permitted during a simulation before they're grounded. AI has no equivalent standard. None. The industry has collectively decided that because the failures are unpredictable rather than systematic, they don't require a threshold. Because the Jagged Frontier shifts with every new model, no fixed benchmark applies. And because the failures are often embarrassing rather than fatal. So far, the question gets deferred until the next version comes out. But the failures are compounding, and the places where AI is being deployed are not staying embarrassing, they are moving. Yeah, fast. Into medicine, into law, into financial systems, into the tools people use to make decisions that affect other people's lives. And at every step, the same logic applies. The next model will fix this. Just wait. Ethan Mollick's warning wasn't just about the failures themselves. It was about the pattern underneath them. AI doesn't learn from its mistakes the way a human does. A lawyer humiliated in court adjusts. A doctor who misdiagnoses changes their process. AI runs the same statistical calculation the next time it's asked. The error doesn't register. The next query runs the same calculation. Nothing learned, nothing adjusted. The same cliff, waiting in the same place. And yet, the money keeps coming. More of it than at any point in human history, because the people writing the checks have convinced themselves that the frontier doesn't matter. That scale fixes everything, that the next $1 billion is the one that smooths it out. Whether they're right or catastrophically wrong is a question we are all going to answer together, ready or not. Before Google's Gemini Ultra was released to a single user, before one person had typed a single question into it, it had already cost $191 million. Just to train. Just to exist. That's the cost of 2 modern F-35 fighter jets. Aircraft so sophisticated, it takes years to train a pilot to fly one. And that $191 million bought one AI model. Not deployed, not refined, not plugged into any product. Just trained, just brought to the point where it could begin, then they did it again with the next model and the next. Training. Grok 4 alone produced emissions equivalent to 17,000 cars running for a full year. Not the data centers powering it afterward. Not the millions of daily queries it processes. Just the training run, the startup cost, the price of admission. And nobody putting money into AI is counting this. Not really. Not in the way that matters. Because when you're moving $285.9 billion, the cost of 17,000 cars feels like rounding error. When your yearly investment in generative AI alone is $25.2 billion. The equivalent of building 17 Burj Khalifas from the ground up. The power bill for a data center in rural Virginia is somebody else's problem, except it isn't. It's the problem of every community unlucky enough to be sitting on cheap land near a power grid. In 2024, demand for AI-driven data services surged by 690%, not grew, surged. And it's expected to keep climbing by roughly a third every year after that. The United States currently holds 43% of the world's data center facilities. And new ones are being approved, built, and powered at a pace that local infrastructure was never designed to handle. The communities around them report heavier emissions, deteriorating air quality, and in some cases, genuine water shortages as the cooling systems for these facilities drain local supply. The tech industry's response to this has been consistent. Each individual query has a tiny carbon footprint, smaller than eating a hamburger, smaller than driving a mile, which is true. And also completely beside the point because nobody is making one query. We have seen this before, not the AI part, the belief part. In 1999, Cisco Systems was the most valuable company in the world. Its routers and networking equipment formed the literal backbone of the internet. The pipes through which the digital future would flow. The logic was airtight. The internet is real. Cisco builds the internet, therefore Cisco is worth $500 billion. Investors poured money in. Infrastructure was overbuilt on a staggering scale. Fiber optic cables were laid across oceans for a demand that hadn't materialized yet. Entire server farms sat dark, waiting for users who hadn't arrived. Then the market corrected. Cisco lost 86% of its value in 18 months. Trillions of dollars evaporated. The infrastructure survived. The internet was real, and the pipes eventually got used. But the companies that had borrowed against the promise of infinite growth did not. Pets.com, Webvan, Cosmo.com, names that once had billion-dollar valuations and venture capital lining up around the block, gone inside 2 years. The technology wasn't fake. The valuation was. And right now, the people building AI know the technology is real. They have seen it do extraordinary things. What they are less certain about, though very few will say it out loud, is whether the valuation matches the moment. Whether the world actually needs what they're building badly enough to pay what they're charging for the infrastructure to build it. The people most directly feeling this aren't the investors, they're gamers, an unlikely coalition of voices pushing back against AI expansion. And for a reason that hits closer to home than emissions data or adoption statistics. DDR4 RAM, the memory chip that powers everything from gaming rigs to professional workstations, has increased in cost. The demand from AI firms has consumed supply so completely that some of the major manufacturers have exited the consumer market entirely, stopped selling to individuals, redirected everything to data centers, so you can't buy the part. Not at any price that makes sense. Not anymore. An arms race doesn't ask whether you want to participate. It just restructures the world around its own priorities and hands you the bill. And the bill for this one is still being written. In June 2025, a research paper landed quietly in the academic world and made an extremely loud noise. It came from Apple. That's worth pausing on, because Apple is not a company known for torpedoing the technology sector. It's one of the most powerful corporations in human history, worth more than most national economies. It has every reason to stay in the club, keep the relationships warm, and wait for the right moment to sell its own AI product at a premium. Publicly undermining the foundations of an industry it depends on is not the Apple playbook, and yet, Apple researchers spent months running one of the most rigorous independent analyses of current AI models ever conducted. They weren't looking to score points. They were trying to answer a practical question. What can these systems actually do? And where did they fall apart? What they found cracked something open. The first thing they confirmed was something most people already suspected. AI is extraordinarily good at retrieving and matching. Give it a problem it has seen before, or one that closely resembles something in its training data, and it performs at a level that looks from the outside indistinguishable from understanding. It sorts through the data faster than any human team. It finds the pattern, it delivers the answer, but the researchers wanted to know what happened when you took the pattern away. They took standard mathematical problems, the kind AI models score well on in published benchmarks, and reworded them. Same logic, same steps required, different surface presentation, not trick questions, not deliberately confusing, just unfamiliar formulations of familiar problems. Performance dropped. Significantly, not uniformly. The Jagged Frontier again. But enough to show something important. The model wasn't solving the problem. It was recognizing the shape of a problem it had solved before and reproducing the shape of its previous answer. Take away the familiar shape, and the engine stalls. Then they introduced the Tower of Hanoi, if you haven't encountered it. The puzzle involves a stack of discs arranged by size on one of 3 pegs. The goal is to move the entire stack to another peg, one disc at a time, without ever placing a larger disc on top of a smaller one. It sounds simple. A child can learn the rules in 2 minutes. But it requires something very specific to solve correctly. You have to hold the entire sequence in your mind simultaneously. Every move affects every future move. You can't optimize one step without understanding its downstream consequences 3 moves later. It demands genuine multi-step planning. Not pattern recall, not statistical prediction. Actual forward reasoning. This is precisely what cognitive scientists call working memory under recursive load. The ability to maintain and manipulate an evolving model of a problem while executing it in real time. It's one of the clearest markers we have for distinguishing genuine reasoning from sophisticated imitation. Chess grandmasters deploy it, surgeons deploy it, architects, engineers, detectives. Any domain where the next decision depends on holding the full shape of a problem in mind requires it. AI failed it. Not immediately, not on the simple versions with a small number of disks, those it handled, but as the number of disks increased. As the required sequence of moves grew longer, as the number of steps between current position and final goal expanded. The performance degraded. It started making moves that contradicted its previous moves. It repeated errors. It got stuck in loops. And eventually, on the most complex configurations, it appeared to give up entirely. Not with an error message, not with a flag. It just stopped producing valid sequences and started generating plausible sounding output that didn't actually solve anything. It didn't say it didn't know. It didn't stop and ask for help. It kept producing confident output. And the output was wrong. The same behavior as the hallucinated court cases, the same behavior as the rock-eating advice, the same failure mode, wearing a different face. And this is where the singularity argument quietly falls apart. The singularity. The moment AI surpasses human intelligence entirely and begins improving itself without limit, has been the load-bearing promise underneath 3 decades of AI investment. It is the reason the numbers make sense. The reason $285 billion isn't insane, because if you believe on the other side of that threshold is a machine that can reason, discover, govern, and optimize everything humans currently struggle with, then the cost is trivially small compared to the return. But the Tower of Hanoi is a 7-disc puzzle. It is not curing cancer. It is not running a power grid. It is not managing a military response to a crisis in real time. It is a wooden toy invented in 1883 by a French mathematician as a recreational puzzle. And at a certain complexity, the most advanced AI system ever built looked at it and started guessing. None of this means the technology is fake. It means the thing being sold. The thinking machine, the digital mind, the system that will eventually surpass us, may not be what is actually being built. What is being built is something genuinely powerful and genuinely limited in ways that its builders have been, at best, slow to communicate, and at worst, have chosen not to. The question is whether the people with $285 billion on the line are willing to hear that, and whether the answer changes anything. The technology was built here, the money came from here, the companies leading the race. OpenAI, Anthropic, Google, Microsoft are all American. The United States has invested more in artificial intelligence than the next dozen countries combined, and Americans don't want it. Not all of them, but enough to make the numbers uncomfortable for everyone betting on mass adoption as the endgame, according to the Stanford AI Index, which has been tracking attitudes toward artificial intelligence across countries and industries since 2017. The United States ranks approximately 24th in the world in the share of people regularly using generative AI at work, 24th. Behind Ireland, behind Norway, behind France, behind countries that didn't build any of this, don't host the data centers running it, and aren't footing the environmental bill for its expansion. Only 28.3% of Americans say they use AI regularly in their professional lives. Only 23% see a positive impact from the technology overall, and only 10%. That number again, the one that won't go away, say they are more excited than worried. Meanwhile, Singapore sits at 60.9% adoption, the United Arab Emirates at 64%. Both countries actively framing AI not as a threat to workers, but as a national competitive asset. Something to be embraced, deployed, and built upon. Their governments have invested in public messaging, in workforce transition programs, in an official cultural posture that treats the technology as an opportunity rather than an encroachment. The technology is identical. The reception couldn't be more different. So what is America reacting to that Singapore isn't? Part of it is the social safety net, or the absence of one. In countries like Denmark or the Netherlands, where AI adoption rates are climbing and public anxiety is comparatively low, a worker who loses their job to automation doesn't immediately lose their health insurance, their housing security, or their ability to feed their family while they retrain. The state absorbs part of the shock. The transition is painful but survivable. In the United States, losing your job can mean losing everything at once. The stakes of displacement are categorically higher. And so the fear of displacement is categorically higher. But there's something else underneath the numbers, something the adoption statistics alone don't capture. Americans have already met AI, not the impressive version, not the Math Olympiad version or the bar exam version. They met it in the customer service chatbot that couldn't understand their question. They met it in the automated phone tree that routed them in circles for 40 minutes before disconnecting. They met it in the AI hiring screener that rejected their application without a human ever reading it. They met the Jagged Frontier, personally, frustratingly, repeatedly, before they ever heard the term Itoyus. And several of the companies that deployed AI in customer-facing roles most aggressively have quietly walked it back, scaled down the automation, rehired the human staff they let go, because the system worked well enough on paper and badly enough in practice that the cost of keeping customers was higher than the cost of the technology it replaced. Nobody announced this. There were no press releases. The rollouts got headlines. The retreats didn't. Here's the automation paradox that the adoption debate almost never addresses. The countries using AI most enthusiastically are not the ones experiencing the job losses that American workers fear most. Not yet, not at scale. In high adoption countries, the early data suggests something more complicated than replacement. Workers are using AI to handle the repetitive, low-value portions of their roles. The drafting, the formatting, the initial filtering, and redirecting their time toward the parts of their work that actually require human judgment. In some sectors, productivity is rising. In some, workloads are decreasing without headcount following. The feared cliff edge of mass unemployment hasn't materialized in the places where AI is most embedded in daily professional life. Which raises a question that cuts both ways. If the job apocalypse isn't arriving in Singapore or Dublin or Oslo, then either the American fear is overblown, or the American labor market is genuinely more exposed in ways that other economies have already insulated themselves against. Both can be true simultaneously. The fear can be legitimate, and the specific nightmare scenario can still be wrong. But nuance doesn't move markets. It doesn't fill conference keynotes, and so the debate stays loud and binary. AI saves the world, or AI takes your job, while the actual story plays out quietly in the space between. What's clear is this: the gap between what Silicon Valley is selling and what ordinary Americans are experiencing is not closing, it's widening, and the assumption that public resistance is just a temporary friction. That people will fall in line once the technology becomes unavoidable. Maybe the most dangerous assumption the industry is making. Because if the public doesn't come along, if the adoption curve stays flat in the country that built all of this, then at some point the investors start asking a question that has no comfortable answer. What exactly did we buy? There are two ways this ends. Neither of them is the version Silicon Valley is selling. The first scenario is the one investors are quietly beginning to price in, even if they won't say it at conferences. The bubble bursts, not because AI is fake, not because the technology stops working, but because the gap between what the technology can do and what the market has decided it's worth becomes impossible to sustain. One bad earnings report from a major firm, one catastrophic public failure from a widely deployed model, one moment where the jagged frontier tears through something it shouldn't have touched, and the confidence cracks. In 2008, the financial system didn't collapse because mortgages stopped existing. It collapsed because the instruments built on top of them were valued as if they couldn't fail. The underlying asset was real. The certainty layered over it wasn't. And when that certainty cracked, it didn't crack slowly. It fell through the floor in weeks. The AI bubble wouldn't be identical, but the mechanism is the same. Valuation built on a promise. Promise built on a milestone that keeps moving, and underneath it all, a public that was never fully convinced. Waiting, not quite patiently, for the moment the math stops working. If that moment comes, the losses won't stay in Silicon Valley. They rarely do. The infrastructure build-out alone. The data centers, the power grid expansions, the supply chain restructuring, and has already embedded AI investment deep into the broader economy. When it unravels, it takes things with it that have nothing to do with language models or benchmark scores. That's scenario one. And to the people who study financial history, I know it's the optimistic one. Scenario two is what keeps the skeptics awake. In this one, the bubble doesn't burst. The adoption curve bends upward. Governments and corporations, reassured by the benchmark scores, by the math Olympiad results, by the cybersecurity success rates, and the medical diagnostic tools, go all in. AI gets woven into critical infrastructure, power grids, financial clearing systems, emergency response routing, military decision support, not replacing humans entirely, but sitting between the human and the decision. Filtering, recommending, flagging, acting. And then something hits the jagged frontier. This isn't hypothetical, it's already happening in fragments. In 2024, a South Korean AI system deployed to assist with public transport routing generated a cascade of errors during a peak load event that took human operators 4 hours to manually unwind. No injuries, no fatalities, but 4 hours of a major city's transit system operating on bad instructions, with human controllers fighting an AI that was confidently wrong and couldn't be told so in real time. In financial markets, algorithmic systems, the direct ancestors of today's AI models, have already demonstrated what cascading failure looks like at speed. The 2010 flash crash erased nearly $1 trillion of market value in minutes before partial recovery. The system wasn't broken, it was doing exactly what it was designed to do. It just hit a set of conditions its designers hadn't anticipated. And in the time it took humans to understand what was happening, the damage was done. That's sir. Now put that failure mode inside a system with the Tower of Hanoi problem baked into it, a system that doesn't know what it doesn't know, that produces confident output when it should produce nothing, that, when pushed past its complexity threshold, stops reasoning and starts guessing. Without telling you, it has made the switch. Now give that system a recommendation inside a nuclear power plant's cooling management protocol, or a hospital's triage routing system during a mass casualty event, or a military command network during an active engagement. You would not hand any of those responsibilities to a system that gets analog clocks wrong half the time. And yet the logic of the moment, the sunk costs, the arms race pressure, the fear of falling behind China or whoever comes next, is pushing exactly in that direction. Not because the people making those decisions are stupid, because the pressure to use the tool outweighs the incentive to ask hard questions about it. Multiple governments have already moved beyond the question of whether to integrate AI into military planning. The United States, China, Israel, and the United Kingdom have all publicly acknowledged active AI involvement in targeting support, logistics optimization, and threat assessment. In 2024, reporting from multiple defense journalists confirmed that AI recommendation systems had been used in active conflict zones, with human operators approving AI-generated target assessments under time pressure that made independent verification functionally impossible. The human was technically in the loop, but the human had 3 seconds to say no. So here is where we are. We have built something genuinely powerful, something that can solve problems that stumped us for decades, that can process information at a scale no human team can match, that has already demonstrated real value in medicine, in science, in security, in creative work. All of that is real. All of it matters. The problem isn't that AI doesn't work. The problem is what we've decided to do with something we don't yet fully understand. We have deployed it faster than we have learned to verify it. We have structured an entire financial ecosystem around the assumption that the failures don't matter, or that the next model will fix them before they become catastrophic. And we are now at the point where the decisions being made aren't about research budgets or product launches. They are about infrastructure, about power grids and financial systems and weapons targeting, about the places where the Jagged Frontier stops being embarrassing and starts being permanent. The clock is still on the wall. It still shows the wrong time half the time. And we are still deciding, whether that matters.